Welcome to RSA Conference 2024. We're here recording live from Broadcast Alley in Moscone West. This interview is sponsored by Deep Instinct. I'm your host, Adrian Sanabria, and joining me is Carl Froggett, CIO of Deep Instinct. Hello,
Thank
Carl.
you.
How are you?
Thank you. Good. Very busy, but enjoying the week.
Yeah? So today, I love the title here, the EDR honeymoon is over.
Yep.
The power of deep learning to combat AI threats. So, yeah, I think we're definitely at an inflection point where we now know the bad guys are organized.
Yep.
They have their own research and development.
It's a business, it's an industry.
They've got their own tech experts.
Yep.
So they have access to the same technologies that we do.
That's right.
And now we have to respond to that.
Yep.
Except they don't have some of the same restrictions that we do in deploying.
They don't have the
those
same
technologies.
integrity.
Yeah, it puts us at a bit of a disadvantage, it would seem. Right?
It does. It does if you take a traditional approach.
Right. So what kind of things are you seeing that they are doing?
Yeah, so look, I think if you look at last year at any measure, we had a record year for ransomware payments.
Yep. Over $1 billion, right?
1.1, I think, was the latest count. We had a record year for the number of data records stolen, and therefore extortion. If you look at vulnerabilities, we had over 26,000, which obviously the bad guys are exploiting. And Unit 42 from Palo Alto, an interesting kind of fact is those vulnerabilities have a publicly published exploit around 23 days on average. So the bad guy, the bad actor, has already got a 23-day advantage over us trying to play by the rules and defend. Yeah. So, the EDR, kind of the detect and respond approach, let's be honest, last year it didn't work.
Yeah.
Bad actors were in Microsoft for 2 months.
Yeah.
MGM.
Well, they're not actually sure. Their logs didn't go back far enough.
And that's a different story, right? But MGM, I think they were in there for 9 days. So where is this EDR, this detect and respond?
Yeah.
It doesn't seem to be working. The bad actors have moved their tactics.
Yeah. And what are some of these tactics we see them using, particularly with AI?
Yeah, so as you mentioned, it's an industry. Obviously, nation-state actors have a different agenda,
right.
But they're using similar tools. The bad actors we generally see with MGM, United Healthcare, they're in it for money, right?
Yeah.
They're looking for the profit, and as you say, there's a whole cottage industry around there. But look at the cost of those breaches, right? MGM was 110 million, I believe. United Healthcare, I mean, obviously they're very publicly getting through a post-mortem with the US government, 1.6 billion in current loss. And then one from last year, Clorox. I like the Clorox one because they initially said, hey, we got breached and it will cost us 27 million. Then they revised it to 49 million, and then it became 363 million. And then they just announced last week they're having a bad quarter because they're still feeling the after effects of that attack and that ransomware. So my whole thing here is, the detect and respond approach has been great for the last few years, but it's clearly not working. It's costing us a lot of money. So we need to be pivoting back to preventing these things from happening in the first place.
Yeah, and it's funny how we went through this, down this path where it was all prevention.
Yep.
And we didn't see the attacks come in, so we leaned heavily towards detect and respond, and just weren't able to make it stick. In a lot of cases, not able to. Like we're detecting everything.
Right.
But a human never sees that in the sea of data that they're drowning.
Exactly.
Right.
There's a lot of noise.
So back to what can we do to prevent it from happening, or at least isolate it when it happens, right?
So the bad guys are using all the latest tools, generative AI. I was here 2 years ago, I want to say, when ChatGPT made a big splash. Following ChatGPT, that 12 months, phishing went up by 1,265%.
Yeah.
The bad actors are, this is a great tool. How can we use it in the attack chain? And obviously, something like ChatGPT was weaponized on the dark web, and now you have these GPTs that will write extremely sophisticated phishing emails that will bypass not only the technology that we have built into email, but obviously when the user looks at it,
it looks legitimate.
Yeah. We're no longer dealing with the prince in Nigeria trying to kind of send you $10 million, right?
Yeah.
Like these are very targeted, sophisticated attacks that even me, having done this for 30 years, I see a few and I have to look at it really hard and kind of understand. So the bad guys have just weaponized the generative AI. The University of Indiana published a paper in January. They looked at over 13,000 LLMs on the dark web.
Oh, okay.
And they analyzed deeply around 212 of them. 93% of them could write sophisticated malware that would bypass EDRs.
Wow, okay.
So the bad guy now, just like we had frameworks back in the day, they have these tools that don't need the expertise. And the thing with the generative AI is it's creating new ones all the time. So historically, we've always had patterns with signatures. You see something bad, you write a signature. Right? EDR, right? You see something bad happens, and then you update your machine learning models.
Yeah.
But like I say, there's a lot of noise, and by any metric that you look at last year, as an industry, we're failing.
Yeah.
And the bad guys are just weaponizing that generative AI.
So I can't imagine that we're going to stop doing the detect and respond. Like we still need to.
I agree.
That it's still that's still a challenge to tackle, and I'm sure we'll continue trying to tackle that. Yeah, I've seen a lot of things that automate tier 1 SOC, things like that. We're seeing a lot of advancements in there and trying to filter out the noise and get to better signal. But at the same time, what more can we do to prevent these attacks or harden against these attacks at the same time?
This is where I joined Deep Instinct because of the deep learning technology. So, AI is bounded around at this conference quite a lot. If you look at most of what I'm seeing here, it's augmenting something bad happened, and now we're going to use an AI to detect and respond, and maybe we can do it quicker. So we're all about prevention first. Why let the bad thing happen? IDC last year actually published pretty damning quote around that as an industry we had pivoted too much, we had given up. We had pivoted, like we can't prevent, we're just going to detect and respond. And they kind of said if we had spent actually a bit more effort in the prevention, we maybe wouldn't be in a bad state. That's what we do at Deep Instinct. We're the only company that's using deep learning, which is a subset of machine learning, a more advanced subset. And deep learning has some unique characteristics, and one of them is that it is able to not only prevent known malware, but autonomously make decisions on new and unknown malware that we've never seen before and prevent it from running and executing. I agree with you. You still need, nothing's bulletproof. You still need the telemetry and the noise, but you should be adopting a preventative posture and not relying on your ability to detect and respond, because the examples I just gave, it's not working.
Yeah. And how is that? So it's a subset of machine learning, and is this something that happens on the back end with you guys, or is it learn adapt for each environment that you put it in? How does a deep learning?
No, it's a great question. So we probably don't have time to get into it, but it's autonomous. So think of a self-driving vehicle. That doesn't make a call to the cloud to say, should I stop at this stop sign?
It's got sensors on it.
We got the sensors, but the brain that's making the decision is very fast, but it's autonomous. There's a little joke around self-driving cars around they don't actually know why that deep learning neural network stops at a stop sign. They're just glad that it does, but they can't explain why. And that's always been a challenge. We have the same deep learning, and like I say, we have many examples where our brain that we give to our customers will prevent malware months after the brain has been trained, because deep learning takes all the available data when we train it on malware, and so because it's taking 100% of the available data, it's able to predictively prevent new and unknown attacks, and that's what we're starting to see the bad guys with generative AI create. What that means for our customers is we're very fast because we have no latency, no lag. We're very privacy sensitive because we're making autonomous decisions. Our customers' data remains in the customer. We never train on customer data. So deep learning,
that's a big concern these days.
And I deployed Deep Instinct in my previous company, and things like GDPR and whatever, like tick box, because none of the data ever left the company. So, and because it's autonomous, we can do things that literally nobody else can. Our biggest customers operate in air-gapped environments. They're not connected to the internet, but our brain is autonomous, like the self-driving car. So we don't need to constantly update it. We maybe update our brain once a year.
Oh, really? Okay.
Yeah. So it's a total paradigm shift for detect and respond. So we're much more accurate, and we prevent the threat from executing in the first place.
Gotcha. And I understand you debuted something called Diana.
That's right.
At RSA conference this year. So Diana stands for Deep Instinct's Artificial Neural Network Assistant.
I'm glad you read that, because that would have been a test.
Yeah. So tell me about that.
So one of the things that we heard from our customers, and I was here last year, was everything I've just explained. So if historically we had patterns, signatures, something bad, we'd write a signature. EDR, detect, analyze, update the machine learning model. Yeah. So there was always a pattern and a history. So our deep learning neural network and what we give to our customers prevents previously unknown malware and ransomware and threats. So the question was, why is that malicious, right? A SOC analyst takes hours to put it in a sandbox and understand why our brain made the decision that it did. Yeah. Diana is taking our deep learning, and combining it, so in seconds it will give you a nice plain English report of the artifacts in that threat as to why it made a decision that it was a threat. Right? Even though we have never seen it before. And nobody else here can do this with unknown malware.
So maybe it tells you what it would have done if it was able to execute?
Yeah, so it tells you, so if you think of an analysis, and a SOC analyst would do this in a sandbox or other tools, and it would take them hours, Diana does it in seconds and gives you the report. So for example, it would say, this file, this Office file, this whatever, makes a call to these URLs which are associated with a Tor network, right? It has evasion techniques that are seen in EDR players, right? So obviously it really breaks down takes you to the code and presents it in a nice report that even my dad could understand if he was reading it, right? Very, very simple. So it's really going to revolutionize the ability of an expensive SOC level 3 threat researcher to get that in seconds, not in hours, and to be able to explain very quickly the unknown unknowns, because the bad actors are leveraging generative AI to create exploits and to create malware. So everything is shifting. Everything will be unknown unknowns, not historic patterns that in my 30 years of doing cyber, we've always kind of had patterns and frameworks of how the bad actors work. That's disappearing. And Diana really helps that explainability as to why something was a threat, even though you have absolutely no knowledge of it prior.
Right. Yeah, it's great. I love seeing this trend where more and more, we've got technologies doing what analysts used to have to do painstakingly, manually in the past. Yeah, and that's a huge advantage.
Yeah, and again, you see a lot of things here with AI that are today kind of, and I'll kind of say trying to speed up the detect side, because then you can respond, right? But there's nothing here that I have seen that is taking the approach of, you know what, I never got paid in my previous role for telling the CISO that I let something happen, but I managed to respond to it and save the day. No, right. The CISO paid me to prevent things from happening. Because obviously, as we see, disruption happens, and it costs us, some of the examples I gave, a lot of money, not only from a revenue perspective, but a loss of productivity, the reputational impact, and then, as I kind of mentioned, the ongoing quarter by quarter reputational loss. So it continues to impact, and ultimately we're very accurate at what we do as well, and again, that's just deep learning. We don't want to disrupt businesses, right? But we do want to be able to say the combination of our deep learning, which is available on endpoints, but we do storage, we do cloud, we can embed into applications, we have an API, so it's very flexible. In a defense in depth, it can literally go anywhere. But then combined with Diana, now we can explain the things that would take hours to explain is now done in seconds.
Excellent. Well, Carl, thank you so much for joining me on Security Weekly today. And to learn more about Deep Instinct, you can visit securityweekly.com/Deep Instinct RSAC. And also check out securityweekly.com/RSAC for this content and more. And we'll be back in a few minutes with another interview.